Imagine waking up one day and realizing that the invisible threads connecting your life to the world have quietly changed overnight. That the signal carrying your ideas, your work, your dreams is no longer limited by cables buried in the ground or towers fixed to one place. That realization is the hook, because it forces a deeper question about progress itself. We often assume speed and scale cannot coexist, that as systems grow larger, they must slow down, fracture, or fail. Yet high above the planet, thousands of machines race around Earth, proving that assumption wrong and challenging how we think about possibility. Starlink is not just an internet service. It is a living experiment in ambition, one that mirrors a mindset that refuses to accept inherited limits. When you look at how thousands of satellites move in coordinated precision, you begin to understand that the real story is not about hardware, but about belief in what is achievable when vision meets discipline. At the heart of Starlink's performance is constellation density, a concept that sounds technical but carries a philosophical weight. Density means presence, and presence means reliability. Instead of relying on a few distant satellites stretched thin across vast distances, Starlink surrounds the planet with an ever-shifting web of nearby nodes. Each satellite is closer to the user, reducing latency and increasing responsiveness. But more importantly, each one is part of a collective that supports the whole. This reflects a broader truth about innovation. Strength comes not from singular brilliance alone, but from systems designed to adapt and cooperate. The network does not rest. It moves, recalculates, and responds in real time, turning motion into stability. In this sense, speed is not sacrificed for scale, because scale itself becomes the engine of speed. Dynamic satellite handoffs are where this philosophy becomes visible in action. As one satellite slips below the horizon, another quietly takes its place, transferring the connection without interruption. The user rarely notices, and that invisibility is the point. Great systems do not demand attention. They earn trust by working seamlessly. This constant handoff is a reminder that continuity is not about clinging to one solution, but about knowing when to let go and move forward. The network anticipates change rather than reacting to failure, and in doing so, it transforms uncertainty into reliability. That mindset echoes the thinking often associated with Elon Musk, where progress is framed not as a straight line, but as a series of calculated risks managed through relentless iteration. As demand increases, especially in crowded regions, congestion becomes the silent enemy of performance. Many systems collapse under their own popularity, revealing a lack of foresight in their design. Starlink approaches this challenge differently by treating congestion as a signal, not a setback. Traffic is monitored continuously, bandwidth is allocated dynamically, and the system learns from usage patterns. This adaptive management allows the network to breathe, expanding and contracting capacity where it is needed most. It is a lesson in humility and intelligence, recognizing that no plan survives contact with reality unchanged. By building flexibility into the core of the system, SpaceX ensures that growth does not become a liability, but a source of resilience. There is a deeper suspense embedded in this story, one that goes beyond technology and into the realm of human aspiration. If a network can grow to thousands of satellites without collapsing, what else might be possible if we abandon the fear of scale? Many ideas fail not because they are flawed, but because they are constrained by assumptions inherited from smaller worlds. Starlink forces us to confront the uncomfortable possibility that our limits are often self-imposed. Watching the constellation expand raises a quiet tension. Are we prepared for systems that are designed to grow indefinitely? And are we ready to think at that level ourselves? Scalability emerges as the true superpower in this narrative, not as a buzzword, but as a disciplined practice. Each satellite launch is not just an addition, but a reinforcement of the entire network. The system becomes stronger as it grows, more capable as it expands, defying the traditional trade-off between size and efficiency. This approach reframes ambition as responsibility, demanding that builders think not only about what works today, but about what will still work tomorrow, at 10 times the scale. It is an invitation to adopt a long-term perspective, to design with the future already in mind. In reflecting on Starlink, the inspiration is not limited to engineers or entrepreneurs. It speaks to anyone who has ever felt constrained by circumstance, location, or expectation. The satellites overhead are a reminder that connection is not just physical, but conceptual. When systems are designed with courage and clarity, they can bridge gaps once thought permanent. The quiet hum of data moving through space becomes a metaphor for progress itself, steady, persistent, and forward-looking. In that motion, there is a promise that challenges us to rethink what we believe about growth, resilience, and the power of scalable vision. Yet beneath the elegance lies tension, because every added satellite raises stakes, complexity, and consequence. And the question lingers whether humanity can match technological reach with wisdom. That unanswered question pulls the listener forward, creating anticipation for what comes next, and reminding us that the future is not guaranteed, only built through deliberate choices made today under pressure, uncertainty, and accelerating global expectations worldwide. As the constellation grows thicker and the sky becomes busier with purpose, the story deepens into something more intense, more uncertain, and more revealing about how progress is actually sustained. Thousands of satellites moving at extraordinary speed are not just objects in orbit. They are commitments that must be honored every second. Each one represents a promise that the system will not buckle under pressure, even as more users log on, more regions come online, and expectations rise. This is where suspense quietly enters the picture, because scaling anything this fast invites chaos, if even a small assumption turns out to be wrong. The network must think faster than the demand placed upon it, predicting congestion before it happens, and adjusting pathways in real time, all while hurtling through space. It is a reminder that ambition without control is fragile, and that true innovation lives in the space between boldness and precision. SpaceX manages congestion by treating the network like a living organism rather than a static machine. Traffic is constantly shifting, users come and go, and entire regions surge with activity during certain hours. Instead of resisting this movement, the system flows with it, redistributing bandwidth, rerouting signals, and leaning on the density of the constellation to absorb stress. The more satellites overhead, the more options the network has, and options create freedom. This is not accidental. It is engineered adaptability, designed from the beginning with the assumption that growth would be relentless. That assumption alone sets the project apart, because it refuses to plan for comfort and instead plans for pressure. At the center of this philosophy is a willingness to accept complexity rather than avoid it. Simpler systems break when stretched too far, but resilient systems are built to bend. Dynamic satellite handoffs are not just a technical trick. They are an expression of trust in motion and change. Each handoff is a small risk taken millions of times a day, and the fact that users rarely notice speaks to the maturity of the design. Stability emerges not from stillness, but from continuous, intelligent movement. That idea resonates beyond technology, echoing in leadership, creativity, and personal growth, where adaptability often matters more than rigid control. The suspense intensifies when you consider what happens if the system ever falls behind demand. A single failure in space can ripple across continents, affecting lives and livelihoods. This is the hidden weight of global infrastructure, the responsibility that comes with touching so many people at once. Starlink operates under the constant pressure of that reality, and the only defense is relentless improvement. Software updates refine routing algorithms, launches add redundancy, and data from real-world usage feeds back into the system. The network learns from its own stress, turning strain into insight. That feedback loop is where scalability becomes more than size. It becomes intelligence at scale. This mindset aligns closely with the broader vision often associated with Elon Musk, where systems are designed not just to function, but to evolve. Evolution requires discomfort, because it forces builders to confront weaknesses before they become failures. Congestion in high-demand regions is not hidden or ignored. It is studied, anticipated, and engineered around. In doing so, the network grows stronger with each challenge it faces. This approach reframes obstacles as essential ingredients rather than threats, suggesting that resilience is not the absence of difficulty, but the capacity to adapt faster than difficulty escalates. As viewers absorb this narrative, a quiet question forms beneath the surface. If a system can handle millions of simultaneous connections from space, what excuses remain for thinking small in other areas of life? The satellites do not wait for perfect conditions. They launch, adjust, and improve while already in motion. That willingness to act, learn, and iterate creates momentum that fear cannot match. The constellation becomes a symbol of compounded effort, where each addition strengthens the whole and pushes the boundary of what feels possible. Yet the tension remains unresolved, because scalability always carries consequences. More satellites mean more responsibility, more coordination, and more potential points of failure. The challenge is not just building big, but building wisely. Starlink's architecture suggests that wisdom lies in distribution rather than centralization, in networks that share load rather than concentrate it. This principle mirrors natural systems, where resilience emerges from diversity and redundancy. The network survives because no single point carries the entire burden, and that insight carries profound implications for how future technologies might be shaped. As the constellation continues to expand, the suspense shifts from whether it can work to how far it can go. Each successful handoff, each managed surge of demand, reinforces the belief that scalability itself is a form of power. It is quiet, methodical, and often invisible, but it changes the rules of engagement. The viewer is left with a growing sense that this story is not finished, that the real test lies ahead as expectations climb even higher. That sense of anticipation pulls the narrative forward, inviting reflection on whether humanity is ready to think at the same scale as the tools it is creating, and whether the discipline required to sustain such systems can keep pace with the ambition that brought them into existence in the first place.